We're going to look at the Markov probabilities. Markov gives us the variables, how they change from one state to another. Like the current state, for example, is our current market share. Say the market share this month, we want to be able to tell, what is our market share next month, or if we run a sales promotion, how that will change the market share. So when we say the current state, for our three competitors, Pepsi, Coke, and other could be like the Dr. Pepper, the Schweppes, the Sam's Club brand, all combined together. This is about what the market share does look like. These are marginal probabilities. All right, so that's our current market share. We also need a transition diagram. This would be research your company did. For example, Pepsi's in black here. It shows Pepsi retains 85% of its customers. In other words, if you bought a Pepsi this week, will you buy a Pepsi product next week? 85% of the people will do that. Our market share indicates that 10% of the people will defect to Coke, and 5% will defect to, I'll call it Sam's brand for lack of a better thing. The same thing with Coke. I highlighted the Coke's transitions in green, and the other I've highlighted in blue. Notice that first of all, our market share adds up to 100%, and for each company, their transition probabilities add up to 100%. So 85, 10, and 5 equals 100%. These are conditional probabilities. What we do with in the Markov is we multiply the marginal probabilities by the conditional probabilities, and we add them up. We get the new marginal probabilities for the next month. These are mutually exclusive and collectively exhaustive. All right. So now we want to find out our market share for our next state or our future state. I've indicated the next time period, which I'm calling next month, by the number 1. So what is Pepsi's market share 1 month from now based on our marginal probabilities, which is our current market share, and our conditional probabilities, which is our transitional diagram. All right, so we have our marginal, Pepsi to Pepsi, or how much market share does Pepsi currently have, times Pepsi's retention rate, so the marginal times the conditional, plus the market share of Coke times the probability from Coke to Pepsi. How many people are going to defect from Coke to Pepsi? Plus the market share of other times how many people are going to leave other and go to Pepsi. So this is read kind of in to from format. So from here to there. All right? So we plug in the numbers. We were given in our current state that Pepsi has a 30% market share and an 85% retention rate. We add that to Coke, which has 42% market share, and 10% of their customers in the transition diagram were going to defect from Coke to Pepsi. Into that, we add the current market share of other, which is 28%, and 10% of their customers were going to defect. So we multiply our marginal times our conditional and sum them up. That comes out to 32. We did the same thing for Coke. Just out of convention, I kind of leave them in the same order. It's just easier for me to do math. So Pepsi times Pepsi to Coke, Coke times Coke's retention rate, and other times other to Coke. Add those up, 44.16. Now one thing we know with our marginal probabilities, they all have to equal 100%. So we could do this out a third time for other, or we could just take advantage of the fact that 100% minus our two other probabilities, we know that other's going to wind up with 23% market share. All right, there's one other thing we can do here. Based on our new market share, we could figure out our probabilities 2 states out. But this time, we know that we're going to use the new market shares. And this is 23, 3, 4. Our transition state, assuming that state constant, which it really should just fall in. All right, and from this we can tell that 2 months out, or 2 states out, that Pepsi's market share would be 34.375%.